All right, here's a continuation of solving equations. So the essential question is, how do I solve a logarithmic equation? A logarithmic equation is an equation with a logarithmic expression that contains a variable. To solve a logarithmic equation, you can change to an exponential and then solve for x. So again, we've seen this one-to-one property for exponentials. Now it also applies for logarithms. So if they both have the same base, then x would equal y. So here is our property. All right, so example 1, solve the equation. So we have a logarithm of base 6. And what we're going to do is we're going to change this to an exponential. So my base is 6. I'm going to raise it to my power of -1. That's my right side. And then the of part equals 2x minus 1. So now it's written as an exponential. Now I'm going to go ahead and change that 6 to the -1 power using my exponent rules. That's 1 over 6 to the first equals 2x minus 1. And then I'm going to go ahead and isolate my x. I'm going to add 1 to both sides. So that cancels out the -1 on the right. So I have 1 6 plus 1 is 7 6. So I combine like terms on the left. And then I want to undo that 2. So one way to undo that 2 is I can multiply both sides by its reciprocal. So 1/2. So multiply both sides by 1/2. So that'll cancel out the 2's. And now we multiply our fractions. So 1 times 7 is 7. 2 times 6 is 12. So x equals 7/12. All right, here's our second example. Notice that these two logarithms have the same base, and the operation between them is subtraction. So we can condense that left side into a single logarithm by division using our quotient property. So we take 100 divided by x plus 1. Now we have a single logarithm on the left. Now we're going to go ahead and change that logarithm to an exponential. So the base is 4, the right side becomes the power, the exponent, and then the of, the parenthesis, becomes the right side. Now I'm going to do is identify that 4 to the first power is 4. And I'm just going to change that to a fraction, so 4 divided by 1. Again, 4 to the first. This right here is 4. I'm just changing it to a fraction now. What I can do next is I can use cross multiplication. I multiply using cross multiplication. So 4 times the quantity x plus 1 equals 1 times 100. Then I'm going to distribute that 4x on the left side, and then 1 times 100 is 100. And then I'm going to undo that plus 4, so I'm going to subtract 4 from both sides. And then simplify, and we get 96. And then we're going to undo that 4, by dividing both sides by 4. And then 96 divided by 4 is 24. So again, what we have done is we've changed to an exponential equation and then solved for x. All right, example number 2, solve the equation. So here's a logarithm. And what we're going to do is use our power property, and we're going to bring that power down in front. So the 4 has brought down in front of the logarithm. Then we're going to undo that 4. So right now that 4 is multiplying the logarithm, so we're going to divide both sides by 4. And then we'll simplify. Log base 5 of x. And on the right side, 8 divided by 4 is 2. Now we're going to go ahead and change that logarithm to an exponential. So it's 5 to the second power equals x. And then 5 squared is 25. So x equals 25. All right, here's 2 more examples on this slide. So we have 2 logarithms. They're both the same base. The operation between them is addition. So we can use our product property, and we would multiply the x and the x plus 1 together to condense it into a single logarithm. So it's log base 12 of x times x plus 1. Equals 1. Then we're going to go ahead and distribute our x. So it's log base 12 of x squared plus x. So now we have a single logarithm. After that, we're going to change it to an exponential. So our base is 12, our power is 1, equals x squared plus x. Now what's different about this problem is a quadratic equation has popped up. So we solve quadratic equations by factoring, quadratic formula, completing the square. So what I'm going to do is I'm going to move that 12 to the right side. So I'm going to subtract 12 from both sides. Now it's in standard form. And we're going to try and factor this. So we have a quadratic trinomial, and the leading coefficient is 1. So we set up our diamond. What are the factors of a, c? So negative 12 that add to b, positive 1. And that would be positive 4 and negative 3. So the sides of the diamond make up our factors with our binomial. Then we would use our zero product property. We set the factor equal to 0 and solve for x. So we get negative 4 and then x minus 3. Solve it and we get x equals 3. Now these are our 2 possible solutions. I'm going to erase the original problem here. When we solve for x, we have to take into consideration if there's any domain restrictions. So for every logarithm, the domain has to be greater than 0. So the domain has to be x greater than 0, so no negative numbers. So in this case, the -4 would not work. So we have one solution of x equals 3. All right, here's another example. So right now we have two logarithms. They are the same base. And the operation between them is addition, but before we can condense them, we need to bring that 3 back up as a power. So there is the power brought back up using our power property of logarithms. Now these two are the same base. They're both base 10 common log. The operation between them is addition. So we would multiply the 8 and the x cubed. So now that's multiplying 8 times x cubed, or 8x cubed. Now notice the base is missing. That's that common log. So I'm just going to put the number 10 in there. And now we're going to change the logarithm to an exponential. So it's 10 is the base raised to the third power equals 8x cubed. Now I'm going to simplify the left side. So 10 cubed is 10 times 10 times 10, or 1,000. Then I'm going to divide both sides by 8 to start to isolate that x cubed. And then I'm going to simplify. 1,000 divided by 8 is 125. And then I'm going to undo that cube. So I'm going to cube root both sides. And then we would use our calculator. And we get x to be 5.